Let's discuss the skeletal, joint, muscle, and contraction. The preparatory phase is the first phase of the vertical jump. This includes bending, either squatting or loading. Now, let's look at the skeletal structures of the vertical jump. As planned, we are just going to cover anatomical aspect inferior to the pelvis. The pelvis is situated at the inferior part of the trunk in the human body. It is located between the abdomen and the legs. The pelvis is a ring-like bony structure composed of the hip bones, ilium, pubis, ischium, the sacrum, and the coccyx. The pelvis supports the weight of the upper body and connects to the femur. The second skeletal structure that we are focusing on is the femur. The femur is located in the thigh. It is the longest and strongest bone in the human body, extending from the hip joint, where it articulates with the pelvis, to the knee joint, where it articulates with the tibia and patella. The femur supports the weight of the body and allows for a range of movements, including jumping. The tibia or shin bone is situated medially and is the larger and stronger of the two bones. It extends from the knee joint to the ankle joint and bears most of the body's weight. The fibula is located laterally to the tibia. It is the thinner of the two bones and runs parallel to the tibia from the knee to the ankle. The last skeletal structure that we're going to discuss is the foot bones, which include the tarsals, the metatarsals, and the phalanges. These structures provide support and balance. For the joint section, we're going to talk about the hip joint, the knee joint, and the ankle joint. The hip joint is a ball and socket joint that connects to the pelvis to the femur, the thigh bone, allowing for a wide range of motion. This complex structure allows for a wide range of movements, including flexion, extension, abduction, adduction, internal rotation, and external rotation, making the hip joint one of the most versatile joints in the body. Next is the knee joint. It is a complex hinge joint that connects the femur to the tibia. The structure allows for a range of motions, including flexion, bending, extension, straightening, and limited rotation. Its stability and functionality are crucial for activities such as walking, running, and jumping. The last joint is the ankle joint, also known as a talocrural joint. Is a hinge joint that connects the leg to the foot. It allows dorsiflexion and plantar flexion. The ankle joint structure allows for essential movements such as walking, running, and jumping, providing both mobility and stability to the foot and leg. Let's now talk about the muscles involvement and the type of contraction in the preparatory phase. The quadriceps, comprising the rectus femoris, vastus lateralis, vastus medialis, and vastus intermedius, undergo eccentric contraction. This means they lengthen while generating force to control the descent and prepare for the explosive upward movements. During the prep phase of a vertical jump, the hamstrings, comprising the biceps femoris, semitendinosus, and semimembranous, the hamstring undergo eccentric contractions during the prep phase. This means they lengthen while producing force, controlling the rate of descent as you lower your body into a squat. During the loading phase of a vertical jump, the gluteal muscles, comprising the gluteus maximus, gluteus medius, and gluteus minimus, undergoes eccentric contraction. This means it lengthens while generating force, controlling the descent as the body lowers into a squat-like position. The gluteal muscles are essential for controlling the descent, stabilizing the pelvis and hips, and storing energy will be utilized for the explosive upward movement during the vertical jump. The calf muscles, gastrocnemius and soleus, undergo eccentric contractions, meaning they lengthen while generating force. This helps to control the lowering of the body as you descend into a squat-like position. The calf muscles are crucial for controlling the descent, stabilizing the ankle, storing elastic energy, and preparing for the explosive plantar flexion that propels the body upwards during a vertical jump. In a nutshell, the quadriceps muscles control the bending of the knees, storing energy in the controlled eccentric contractions, whereby the hamstrings and gluteus maximus control the flexion of the hips, also through eccentric contractions. The calf muscles, the gastrocnemius and soleus, control the ankle movement as they stretch in an eccentric contraction. During the takeoff phase of a vertical jump, the joints, skeletal systems, and the muscles inferior to the pelvis undergoes coordinated movements and contractions to generate the necessary force and motion. Let's look at the joint section. For the hip joint, the hip extends rapidly as the leg pushes off the ground, driven by powerful contraction of the hip extensors. From the knee joint, the knee extends as the quadriceps contract to straighten the leg, providing a strong propulsive force. At the ankle joint, the ankle undergoes plantar flexion, where the foot pushes down against the ground, primarily driven by the calf muscles. Now let's look at the skeletal systems. The femur acts as a lever for muscle attachments, transferring force from the muscles to the ground. For the tibia and fibula, provides structural support and acts as a conduit for the force generated by the muscles. For the bones of the foot, it distributes the balance of the forces to help for dorsiflexion. For muscles and contractions, hip muscles that includes the gluteus maximus strongly concentrically contracts to extend the hip and drive the body upwards. For the thigh muscles, quadriceps concentrically contracts powerfully to extend the knee, providing a strong push-off force. For the calf muscles, gastrocnemius and soleus concentrically contract to explode in a very strong plantar flexion to push the foot off the ground. In summary, during the takeoff phase, the joints, skeletal system, and muscles below the pelvis work in a highly coordinated manner. The hip, knee, and ankle joints extend forcefully, driven by powerful concentric contractions of the gluteus maximus, quadriceps, and calf muscles. The last phase is the landing phase. During the landing phase of a vertical jump, the joints, skeletal systems, and muscles below the pelvis work together to absorb the impact and stabilize the body. These are some of the joint movements. Hip joint. The hips flex to absorb the impact as the body descends. The knee joint movement. The knee flex to help dissipate the force of landing. Last, we have the ankle joints movement. The ankles dorsiflex to help absorb the landing impact. Let's look now at the muscles and the contractions. Hip flexors, gluteus maximus, engage eccentrically to control hip flexion and absorb shock. Thigh muscles, quadriceps, contract eccentrically to control knee flexion and absorb the landing impact. The calf muscles, gastrocnemius and soleus, engage eccentrically to control the ankle dorsiflexion and help absorb the impact. During the landing phase of a vertical jump, the body undergoes a coordinated process to absorb impact forces and stabilize itself. The hip, knee, and ankle joints flex to dissipate the forces, with eccentric contraction of the glutes maximus, quadriceps, and calf muscles play a crucial role in controlling the descent and shock absorption. Vertical jump training enhances sports performance by improving explosive power, strength, and overall athletic ability. Sports like basketball, football, rugby, track and field. How? By engaging in plyometric exercises, strength training, and core training. Incorporating vertical jump training into regular fitness routine can significantly benefit athletes across various sports, enhancing both physical capabilities and mental. Now let's look with our second segment, ball throwing. Performing a ball throw in sports like basketball, netball, and soccer involves coordinated movements of various skeletal structures, joints, and muscles, along with specific types of muscle contractions. Let's start with the skeletal structures. Let's look at the humerus bone, the upper arm bone, radius and ulna, the forearm bones, shoulder girdle, scapula, the shoulder blade. We have the clavicle, the collarbone. Chest area, we have the sternum, which is the breastbone. Last but not least is the ribs, which protect the thoracic cavity. Since now we know about the skeletal bones, let's see how these bones join up. We have the shoulder bone, the glenohumeral joint. Is a ball and socket joint, allowing to move in all axes. We have the elbow joint, a hinge joint allowing flexion and extension. We have the wrist joint, condylite joint allowing flexion, extension, and some degree of rotation. So now let's look at the muscles involved. We have the shoulder muscles, the deltoids, assisting in lifting and positioning of the arms. We have the rotator cuff muscles, supraspinatus, infraspinatus, teres minor, subscapularis, which stabilize the shoulder joint. We have the chest muscles, pectoralis major, primary muscle for bringing the arms together to push the ball. We have the upper arm muscles, biceps brachii, assist in elbow flexion. Opposite, we have the triceps brachii, responsible for elbow flexion during the push of the ball. The forearm muscles, the flexors and extensors muscles, which help control wrist and finger movements. We have the core muscles, the rectus abdominis, obliques, and transverse abs, provide stability and generate power from the torso. During the preparation phase, various joint and muscles along with specific types of muscle contractions happens. So grip the ball, fingers spread, thumbs behind the ball. Flexion of elbows, biceps brachii contract to bring the ball towards the chest. We have the shoulder flexion, deltoids and pectoral major engage to position the arms. In a nutshell, during the prep phase, you can see how the deltoids, the pectoralis major, and the forearm contracts together to prepare for a throw. During the execution phase, the extension of the elbows, tricep brachii contracts concentrically to push the ball forward. We have the shoulder horizontal adduction, pectoralis major contracts to bring the arms together. Wrist flexion and finger extension, forearm flexors and extensors works to release the ball. During the follow-through phase, the arm extension, complete extension of the arms, triceps continue to contract. Then we have the wrist and finger extension, complete release of the ball with controlled follow-through. By coordinating these skeletal structures, joints, muscles, and contractions, an effective chest pass is achieved, allowing the player to deliver the ball with accuracy and power. Enhancing a ball throw involves improving several aspects of anatomy and biomechanics. Here are some of the key focus. Strength training, the shoulders and the arms. Strengthen the deltoids, biceps, and triceps for better power and control. Flexibility and mobility. Shoulder flexibility maintain a good range of motion on the shoulders to prevent injuries and enhance throwing mechanics. Biomechanics and technique. Proper mechanics focus on proper throwing techniques, including the wind-up, strike, arm action, and follow-through. So by combining these elements will help improve the overall mechanics and power of your throw in sports like soccer, basketball, and netball.